Well, welcome everyone to my talk. I'm so excited that you all came here and chose to listen to this presentation. Um, my title slide, just get rid of some of these notifications. All right, so title is Mapping Iconic NYC Sandwiches with AI, Scraping, Geocoding, and Sharing a Map of the New York Times Top 57 Sandwiches. And I'm Dan DeWitz. I'm a data scientist who lives in Lower Manhattan. All right, so the tagline for this talk is, does AI help me build a sandwich map, or does it lead me into a pita pit of despair? So the focus is going to be on using large language models, in this case, ChatGPT, as a pair programming partner, exploring that process, having ChatGPT write code for me, and also kind of brainstorm ideas. So I will be using Python, and in some elements, I'll be going deeper. Others, I'll kind of be glossing over. Really just kind of what fits this grander narrative of, developing or coding with AI. But even if you don't know any Python, um, or don't want to learn any Python, hopefully you can still get something from this talk. All right, so kind of the origin story is it was the summer of 2024. I was lost and uncertain of where to find good sandwiches in the city. So I was excited when New York Times launched this 57 sandwiches that define New York City. This, beautiful website, fabulous images of sandwiches. But the problem was when I was out in the wild, out in the city, it was just too cumbersome to scroll through this, find a sandwich I wanted to eat, and then figure out if it was close to me or not, especially certain sandwiches like that have multiple locations, and other ones that have more cryptic addresses. So it was too hard to scroll. And then I had a vision. Um, to walk amongst the sandwiches, I needed the sandwiches to be map markers, aka I need a sandwich map. So let's turn to AI and have ChatGPT build a sandwich map for me. Just gotta get myself oriented for a second. All right. So I tell ChatGPT, build me a sandwich map from this website, 57 sandwiches that define New York City. Give it the URL. It says it can't scrape that website directly. However, Beautiful Soup is an option to use. And then I asked ChatGPT, I need you to scrape the website located at the URL below. And it tells me it can't directly scrape. It's behind a paywall and legal restrictions. So be sure not to tell them about this talk. Okay, so that brings me to LLMs can't create sandwich maps because LLMs can't create new knowledge. Sandwich maps equal new knowledge. Bold statement, but perhaps I can get your perspective on that at the end of this talk. All right, so ChatGPT can't build me a sandwich map, but I do know a little bit about web development, at least enough to get started. And so crucially, I know that if you right-click an element on a web page, hit inspect, that Google Chrome has a great set of developer tools, and you can easily see specific elements related to specific text or images on the web page. So here I'm particularly interested in the sandwich. Then I'm coming over here and just seeing, is there anything that could be a unique identifier for sandwich name in this website? And it looks like the New York Times did us a solid here and had the class sandwich name. So then before I did right-click inspect, this time I'm doing right-click view page source, control find, control paste, put in the tag sandwich name, and then what I'm looking for here is this 1 out of 57. So that tells me that sandwich name shows up in the HTML 57 times. That's good because the name of this website and this list is 57 sandwiches. So that's promising to get started on web scraping. I also need some other information. So I need the restaurant. Restaurant name also looks promising. Again, 57. Okay. Images. Images might not be so easy. We have this G image element. What do we got there? Okay, 72 of those. Text. I think I'm just going to grab it all. That whole identifier in there, I can see 57. And then the last thing we need is this address here. And it has the tag metadata. And here, interestingly, I only see 56. I spent a lot of time on this website, so I know that the controversial inclusion of your nearest bodega does not have an address because they're on almost every block. So 56 is what we'd expect, and it looks like we're in business. All right, so it couldn't just build me, ChatGPT couldn't just build me a map, but what if I give it the exact class names, or give it the names, the common names with the exact class names, tell it to parse the HTML, and tell it to use the Python package Beautiful Soup. When I do that, here, and I put these prompts in before the talk because it takes ChatGPT a second to actually generate the prompts. So just to be explicit, I submitted this prompt, which is related to this section of the Jupyter Notebook, which is in my GitHub repo, which is linked on the project page. And I'm in this file here, create sandwich map. Okay. So if I give ChatGPT just kind of those common class names and the Python package to use, it actually nails it. This works perfectly. But how I'd actually approach this is I would break this down step by step. So beginning with kind of the first part of this script, I see that we have soup, beautiful soup, HTML parser. And so I'm wondering what that is. So I'm importing the Python package, beautiful soup. And the talk, again, this talk isn't really about Python per se. As far as Python packages, really all you need to know is that there's kind of the core Python language, the standard library, and then there's third-party libraries, open source libraries that basically you just grab from the web and download. Beautiful Soup is one of those, and it's like the most common, simple web scraping package. So essentially, I just give Beautiful Soup, I tell I want a response text, an HTML parser. ChatGPT wrote this, so I don't really care about that too much. What I do care about is what is the soup, and I can see that the soup is this HTML from our Top 57 Sandwiches website. Okay, so after that, and then the other part from this script that I see is that there's this soup find all class equals sandwich name. And so just gonna copy that in a second. So what is that doing? I can see it is grabbing a list of every time this class has appeared. And the text that I'm particularly interested in is bacon, egg, and cheese, chorizo, the actual sandwich name, and not this other information surrounding it. In this case, the H4 HTML header tag. All right, and so the length. And so now I'm taking that Python list and then wrapping it in this length function, asking how long it is, and what I want to see is 57. So that tells me that I got all 57 sandwiches. And so now I'm just repeating that for each of my classes that I identified: sandwich name, restaurant name, metadata, text. And then there's this additional step, tag. For tag in soup, if we saw here, each of these is in the list. So when we say for tag, we're saying for each element in the list, append tag text strip. Basically, what that means is we're just getting this text, stripping the white space. All right, so I run this. I print the length of every list. And so I see 57, 57, 56, which I know is due to your nearest bodega, and then 57. So sounds like I have everything I need. And then I'm just going to take a look at the first and last item. I see the first restaurant is your nearest bodega. Last is Bonnie's. And so I want to make sure that that is true and that it is, in fact, Bonnie's. So doing well so far. And then images. I know that images need special handling because, again, when I do soup find all, finding all of the image tags here, we know already that there's not 57, there's 72. So I'm going to look at this list. And what I notice is that this breakfast sandwich, that's from your first bodega. But then there's kind of these random ones up top. And so if we recall, the website at the very top has this thing flipping through all the images. And so when I go to Breakfast Bangers, I can inspect that. And so it tells me that breakfast 1 is the first one. Then I also see when I scroll, I get a breakfast. Well, I should get a breakfast 2. Nonetheless, you can see it here. There's a breakfast 1 and a breakfast 2. So we need to remove those first 6 images. And here, this is saying basically skip the first 6 I always mess up if it's inclusive or not, but chop off the top sandwiches we don't want. And this means an empty after the colon means we want the rest of the list. All I'm looking at here is that it does in fact start with breakfast 1, which, just to be clear, is our bacon, egg, and cheese. Get rid of that, and here I'm just saying save this list with the top cut off of it to this new variable called images short. Now I have 66 sandwiches in that list. And so kind of my quality assurance check here is that we have 9 sandwich categories. We have breakfast bangers, hero worship, vegan. You get the point. There's 9 of them. So each of them has 2 images with it that display as you scroll. So 57 plus 9 is 66. So that tells us we have all the images we want. But in this last step, okay, so I did do that. What I'm looking at here in this images list is, yeah, there's breakfast 1, 2, there's the fiaco 1, 2, the vegan 1, 2, and basically I'm just making the decision to choose the one that ends with a 2. And so I did have ChatGPT do this for me. And my prompt was just, I need to find all the images with the class gimage. If the URL does not contain big assets, store it in a list. If it contains big assets, make sure it also ends with -2 PNG. And that's something that ChatGPT can handle pretty much flawlessly. But of course, you have to get to that step first of where you can actually describe it. You have to do the research, looking at the HTML from the website to describe it clearly in text. Anyways, yeah, so got that from ChatGPT. I can print out the first image, which is now my bacon, egg, and cheese. And then my last image should be that. And just do a quality check. And that is indeed my last sandwich. So far, we've created the variables restaurant, sandwich names, metadata description, and valid images. And so I'm just going to print all these lists. We see that metadata still does not align, but we do have now exclusively 57 valid images. And then metadata, here I'm just printing the first element again, and you can see that the description is all for your nearest bodega, but then the metadata doesn't align with your nearest bodega. So what I'm doing is popping off the first element for the bodega information. And so this is just saying take that list, remove the 0th element. Python is 0-based index, so remove the 0th index or the first. And now they all have 56 elements. The first element is all for this chorizo egg sandwich, and then the last element, as we've showed a couple times now, all align with Bonnie's char siu BK rib. And then I need to turn the lists into a data frame. So most people are familiar with Excel sheets or Google Sheets. Essentially, a data frame is Python's representation of a Excel spreadsheet, Google Sheet. And so what we just created was each list is a column in our spreadsheet in this case. And here we're just defining the column name. Here I'm just naming them exactly the same, but this could be anything. So create that data frame, and then just to be super clear, we now have our data frame, or our in-memory spreadsheet, if you will. And then, is this data tidy? I think I have a slide for that. So tidy data rules are just each variable is in a column, each row is an observation, each cell is a single value, and you know what uniquely defines a row. That's my additional rule. And then also, this is just kind of how most people intuitively work with spreadsheets. Generally, you aren't putting, a bunch, in this case, you wouldn't put a bunch of sandwich names into a single cell. So brings me back to this. Is this tidy data? And the answer is almost. The only thing going on here is we have the address, the price, and the website all in the same cell. This is a fairly simple problem. Here I'm just selecting a random index. So this indexing here, metadata 0, I'm saying go to this column, metadata, and then the 0th row, and where they intersect right here, 178 East 7th Street, is the value that's going to be selected, and in this case printed out. I guess one thing in my work as a data scientist, I feel like pre-ChatGPT, I wouldn't have added a random draw because I usually don't remember random, rand int, and like these parameters off the top of my head. But now this is something that is pretty simple. And so GitHub Copilot is the built-in AI assistant for VS Code. I think you can use it with other editors too, but if I hit Command I, it pops up this Copilot chat, and then I'm just gonna say take random draw from DF. And accept. Okay, it's using here the sample. All right, so maybe I should actually have that memorized. Okay, well, Pit of despair. All right, so moving on, splitting. We need to get some data out of this metadata column. So I can see it looks pretty consistently that the first element, it looks like this string, this function here, string.split, is splitting this string on the commas. And so it's splitting it into 3 elements. And then when I say, all right, and so then I say I want the website, the -1 means I want the last element. Then I'm just printing this out here, and it looks like it's successful. Got daily provisions, and then Shake Shack. And so doing the same for address, this time selecting the first element or the 0th element. And we do know we have this multiple locations problem that we're gonna have to deal with at some point. Kennedy International Airport, that looks good. But price, we have our price there. But for the airport, we get terminal 4. So just to be clear, our price here, this address 0, price 1, website last. is disrupted because Kennedy Airport adds this unique Terminal 4 element. And so then to effectively parse out the price, I did use a prompt and I said in that column metadata, the price starts with a $sign, grab the integer following the $sign, and then store it into a new column called price. And this is what I used exactly. And I would say professionally, I do offload almost all regular expressions to AI now, but then it is important you can take this line of code and say, hey, tell me what it's doing, and that you go through it line by line and actually make sure you understand the regular expression. All right, and then just making sure, selecting a price, making sure it is indeed a number. If they all are integers, I should be able to take the mean, and I can. So the average price is $15.93. This Python function value counts is one that I use all the time. Here I can just see $17 is the most common sandwich. And then one quick plot, and you can, we have a pretty normal distribution, but the cheapest sandwich is 5. Most expensive is $45. Okay. Yes, and just one other thing is that, I also, before starting this project and brainstorming, I did have a rough project outline, so just kind of outlining what we're going to be talking about today. Web scraping, we just finished that. Geocoding will be next. Create an HTML template, and then finally publishing it to the web. But before that, I do have a trivia question. And if you could just answer in the chat, who invented the sandwich? Was it John Montague, Earl Sandwich, Gordon Ramsay, or Earl of Sandwich? And so that was also a lot. If anyone has, and if you are able, if anyone has any pressing questions that they want to come off mic for or relay any questions from the chat, now would be a good time for that too. I'm just going to take a peek at the chat. We have some D's. No, you can't use Google Gemini. A lot of D's. The correct answer is, it's actually both A and D, John Montague, who was the Earl of Sandwich. Very important. All right, so that brings us to the next step, which is geocoding. Yes. Okay, geocoding. For me, I just want to get sandwiches on a map, and I know the markers need a latitude and longitude. And so essentially geocoding for me is a black box in that I want to just send the address and I just want to get the latitude and longitude. For this, I also know I want to use Google Maps API mostly because I have used it before, and I guess I'm an avid Google Maps user in general. Okay, and I will say, yeah, so Google Maps API, we're not really going to cover it. It's free for the most part for most things you want to do. I think 3,000 requests. Essentially, an API key is just a password that's auto-generated for you. If you do this, be sure to restrict which websites can call it, because one of the API keys we use is like essentially public. And if you need help with this, ask ChatGPT. All right, so hopping into this, the prompt I used is I want to geocode addresses using the Google Maps API. The addresses are stored in the column address, and I want to send the API the addresses and get the latitude and longitude as new columns in my data frame. And I also want to return the status of the API call and the formatted address from the API. And just to prove that works. Again, once I'm able to define what I want clearly in writing, it actually created a perfect code, basically exactly what I wanted. I guess perfect might be debatable. And so when you're working with the Google Maps API key, essentially you just give it your API key and generally you're good to go. Here I have my API keys stored in this environment file. And here I have a fake version. And all I'm doing is basically storing my API key to a variable. And then this load.environment package just looks in that .env file, finds here the Google Maps geo API key, and then saves it to this variable. If I were to print this like this, it would just print the string, which is my password. So I'm not going to do that. All right, hope this works. And so basically I just ran this straight from ChatGPT. Here I'm just saying, show me the columns. And I'm expecting a latitude, a longitude, and API status. All right, so value counts, API status. I can see that 46 of them have the status okay. 10 have 0 results, which I'm expecting some to have 0 results because of the multiple address problem. Just going to take a quick look at these. And I can see mostly what I'm looking at here is, does the address and the formatted address, when I do have results, when the results are okay, are they the same? And here, because there's only 57 sandwiches, you can get away with doing that visually for the most part. I do see this one that's problematic because it's Manhattan Avenue, Nassau Street. I think that's a problematic one. I'll show that later. But in general, it does a pretty good job of getting latitude, longitude, and accurate addresses, which there I was just looking at the addresses to make sure using the formatted address is just a quality control check. And so I'm going to separate out every row that has a status of okay. I'm going to say for my data frame in the column API status, where that status is equal to okay, I want to keep those rows. And so now this should be 46, which matches my row count right here. Do the addresses look reasonable? Yes. And then now I'm doing the opposite with the bad results. This is just selecting which columns I actually want to see. And so all of these guys have no results. They don't have a latitude or longitude. And for the most part, there are multiple addresses. There's this one address for Little Egg that I couldn't find. All right, so that brings me to the second part, which, okay, so multiple addresses obviously isn't going to work. That means I need to query the Google Maps API restaurant by name, which is stored in the column geodf bad restaurant. Then on the same data frame, return the columns format address, restaurant name, latitude, longitude, API status, etc. This did take me into a pit of despair. It actually took me a while to kind of arrive at this strategy where I'm actually just looping through the data frame, calling the Google Maps API based on the restaurant name, and then that returns this place that returns this results JSON object. And then from that, I'm grabbing the name, the formatted address, and the latitude and longitude, which you can see here. Takes some fairly sophisticated indexing in the JSON object to actually get correct. I'm not going to go into that here now, but that should work. And usually doesn't take that long. All right. So now for the bad results, I can look at these and see that, for example, let's do Mama's 2. I now have both restaurants, latitude and longitude. But I also have some problems on the Zane's famous foods. I know some of these are not what I want. Bites of Zan, Old Zan, etc. Bikes of Zan 32. Some of these are new. Each time I run this, I do get a little bit different results. So here I'm just trying to remove the restaurants by name. And then I'm taking United States out of the address. And this should look a little better. I, for the most part, only have the Zane famous foods that I want. Here I'm just checking that my data frame is unique on restaurant and address. It is. I'm doing the same for the GODF. Okay. And then essentially I just concatenate those two data frames together. Now I have a data frame of 94 rows. Separately, they both add up to 94, so that QA check is good. And then I need to know what uniquely defines a row, which here is sandwich name and address. So that should equal 0, meaning that there are no duplicate values. All right, so creating the HTML template. There are a few things I knew coming into this. I knew I wanted to use Bootstraps because it's a very simple framework to make flexible, mobile-first, lightweight web pages. And so I know that this thing needs to look good on my phone because that's when I'm going to be looking at the map. And then I knew that Bootstraps has this thing called a modal, which on their website, they have this live demo that pops up and does a full page fill. And so I was thinking that this would be really good to put all of the sandwich information. And so I fussed around with that for, quite a while. And then I actually took my template and said, hey, ChatGPT, write me a prompt to create this template. And that's what you're seeing here. So generate an HTML template that displays an interactive Google map with custom sandwich markers. When a marker is clicked, a Bootstrap modal should appear showing sandwich details. I list them all. I list the variable names I need, and then I give an example of the data structure that I'm going to be providing. And then it created this event handling section. I know I want the map to take up the full screen. And it should have a header and footer. And then it should all be contained in one HTML doc. That's basically what this query is saying. So I take that, which I wrote here. I can take this code, put it in my test map. And so I have my spare API key up there at the top. I know that I need to swap out this line right here where it says your Google Maps API key with my active API key. And then I save that. I can go into my folder structure and see test map HTML, click it, Boom, I have a sandwich on a map. I click the map, a modal pops up, and it tells me restaurant information, price, description, location. Does the website link work? Yes. No. Yes, it does. And then the other thing is directions. Boom, that works too. All right, so that's only one sandwich. How do I get all the sandwiches on there? And essentially what I'm doing is, so we have this geocat df, which was our two geocoded data frames concatenated together. I'm basically looping through every row and then creating this Python dictionary, which matches the template object that we gave ChatGPT. So I'm just going to do that, and they're stored in this list locations. Go ahead and take that off. Now, so this is each of my sandwiches stored in a Python dictionary. And I open that in text editor. And I'm just going to copy it. Go over to my test map. And then I don't think I got those. So paste it, save, reload. All right, I have all my sandwiches. The only problem here is that I mean, this isn't quite my vision. The backgrounds, the white backgrounds, it's not quite doing it for me. And then the other thing is, you can see these are all perfect squares, which to take care of that. And so what's going on here is we can see that it's binding our data from our data structure here to these marker elements that are activated on a click. I really don't know how this works, but I can identify, where my variable names and data are coming from. But to make the sandwich markers look better, all the images are rectangles, so just changing that to 90, which means 90 pixels on the x-axis, 50 on the y. Boom. Now these are looking much better. And then, of course, the last thing is removing background images, which, just like the API, I just want to send an image, get the image back. And for that, this also was a little bit of a pit of despair. ChatGPT led me towards several other Python packages, which I actually couldn't get as installed locally. So that could be a me problem. But I ended up finding out about the ImagePig API on Reddit. And so here I go to the docs, find background removal, usage examples, and then I just grab this bit of code and I said, ChatGPT, I need to use the API below, remove background images. And here I'm representing chain of thought approach. So I started simple. And then after it produced that code, I said, okay, now I need to write the images to an output directory, check if it exists first, if not, create it. And then I said, name the image after the sandwich name. And then I said, there's a rate limit. I can only submit two images per minute. And again, this one, ChatGPT pretty much nailed. And so I'm not going to run it because it takes like an hour. But you can see here we have our processed images, all named after a sandwich. I also like, for the rate limit, it used the modulus operator, which got me thinking. I don't think I've ever actually used that operator organically on my own. Don't want to give too much maybe about my coding skills, but we look at these images and, well, That one's pretty bad. But for the most part, they're identifiable. Here, okay, maybe they're actually kind of bad. Anyways, you do that, and then the process is to recreate that same dictionary again, this time with the additional image, no background. And then we can see we do have a actual sandwich map, iconicsandwiches.com, which is live. Sometimes you have to reload it a lot. And here we are. We have our sandwiches. And so I did some more formatting just on my own, but this is kind of what I ended up on, and I'm pretty happy with it. I do know that there are some quality assurance errors. So this, it says right in the description, green point. Perhaps that is actually something we could use AI to do, to say, hey, does the description reference a neighborhood it's not in? It's also fun to zoom way out. So no surprise that most of the sandwiches are centered around Lower Manhattan. Yeah, if you go out far enough, it's like the sandwiches are taking over the world. Yeah, and so there's only one last thing to kind of touch on before we get into questions, is actually launching the map. So for that, I'm using GitHub Pages. And so we have our repo here. There's this file just named index.html, and that's where our actual live map is. And so you have to set up Pages by going to settings, pages. Here I just bought this domain, www.iconicsandwiches.com. You link it here. Make sure that it's deploying from the correct branch. That's one thing you have to do. The other is you have to create this CNAME file and also put your domain name in there. Then you also have to create this workflows pages deploy YAML file, which for this I used actually this little guy, this AI copilot. And then you have to go to where you bought the domain from. In this case, I used GoDaddy, and create a CNAME attribute here and point it back towards your repo. And then after probably a few rounds of trial and error, you might be able to see it online. So that's how I shared the map with GitHub Pages. And so to conclude here, I'm going to say, how helpful was AI on a scale of Pita Pit of Despair to Sandwich Mountaintops? I'm giving it about a 7.8. And then just to get philosophical for a second, why learn AI? So because Sandwich Map, maybe as you just saw, it is helpful. I think it does make coding more fun. I do feel like I get less stuck on just kind of weird syntactical issues using Python. And I do think it does help me explore a little bit more. But maybe you've also heard quotes like this. I'm pretty sure Sam Altman said this: AI won't take your job. Someone using AI will take your job. I think this is pretty grim. I want everyone to have a job. And I also don't know if fear is a great motivating factor for learning something. But there is, certainly this question with AI that can't really be ignored, is that, we're unsure if, AI will actually let us focus more on interesting work. I work in data science, so will I spend less time actually, wrangling data and doing somewhat rudimentary data processing tasks, or will AI let me focus more on modeling? Uh, it remains to be seen. Or will it just reduce the need for engineers, data scientists in general? Also, maybe don't learn AI. Perhaps you've seen headlines like this: frequent users may be more lonely, could impact creativity, might make your writing worse, which I think is interesting. The idea there is that when you're writing, it's kind of actually really important to struggle with producing the perfect sentence, generating that idea, thinking about your audience, and that if you turn and that's that's a skill, that's a muscle, that's something you need to practice. And if you are always turning to AI, it's an ability you might lose. I think that makes sense in some capacity. Here, I don't really care if I don't know the Google Maps API or the background image removal for the one time I need it. But I think, the best reason to learn AI, or maybe one of the most holistic reasons, is this quote I recently saw. Our tools are not always at our beck and call. The less we know about them, the more likely it is that they will command us rather than the other way around. AI is not going anywhere. And I think it's not crazy to think that it's going to change us and our behavior and how we see the world in some way. And that's from the book More Work from Other, which is fantastic. Highly recommend. So on that note, next steps, I want to make the images smaller so they load faster. That's the marker images. Right now I'm just using the full size images. Maybe adding a filter would be nice, or some way to identify the vegan veggie sandwiches. Other ideas. And so now, question, comments, sandwich recs, anything anyone wants to contribute.
So just heading back to earlier in the chat, there was a question about can we use Google Gemini or Copilot? I believe you said no, but I think we were wondering if you could expand on that.
Oh, okay, I wasn't sure if they were asking about to answer the trivia question or not. Um, as far as using different models, from my experience, I would say they're relatively the same. Um, I don't know. This is something that's, I think, really hard to actually compare robustly. But, in my work, I haven't noticed actually a ton of difference between the different flavors of LLMs, either OpenAI's or Google's or Microsoft's or even Gronk. I've never used Gronk, but X's AI. So I don't know if that answers the question or not, but um, yeah, I don't know. They all seem to be fairly similar to me.
And then next up, there's a question here saying, I'm confused how you got all the addresses for the Xeons.
I mean, that was a pit of despair, but so what I actually did there is, so right here, um, there's a bunch of them, of course, and so what happened is, so the Xeons we know had multiple location. I guess we're just trying to be explicit, but we know that they have multiple locations, so then, they didn't work on the first pass. And so to get them, I did a second pass. I separated all of the addresses into their own data frame that had multiple addresses, so they didn't work on the first pass. So this data frame is named GODF bad, meaning they didn't work. And so instead of sending the Google Maps API an address like I show here, I actually sent it the restaurant name. So it just says, hey, Google, here's the restaurant name. Give me all the restaurants with the same name. So not very robust. And that's why we got a bunch of Zans. And you can also see it gave us matches for so it said this one matched Zan's famous food. So it gave us more than, it's not an explicit direct match. I'm not exactly sure how it works. But But anyways, that was the strategy. Instead of using address, using restaurant name. And then of course, because this is small data, I can check it visually. If this was thousands of sandwiches, that would be a different project. So yeah, hopefully that answered the question.
There is a couple more here. So from K. Adam White says, was curious how did it go to identify and format the sandwich data on the page as JSON? By pasting JS into the browser console, got it down to this. Then he posted something from JSON here in the chat.
Yeah, I mean, all I can say on that is I probably don't really know exactly. Now this chat. Okay. And I think we're probably on the same page here so, the strategy was to just create basically a JSON object or a Python dictionary. They work the same in this use case. So just looping through my data frame, geocoding, creating a JSON object for each row. And then here I'm just printing it. And then obviously opening a text editor, copy and pasting it in. As far as that specific piece of code that was referenced, yeah, I don't know. So basically I just, had ChatGPT generate this for me. And then like I can actually QA it visually because it's a map. And so I didn't really take a deeper dive besides seeing how the data is binded to these listeners from my original data structure. So essentially I just did this, highlighted the text, and then just see how it permeates through the program. Yeah, that's all I got for an answer there. Sorry.
So I have a question here from Emily Powers. It looks like there's parentheses. So it says parentheses are a problem, question mark.
So the parentheses here is actually so, and then I'll make this 6 as well. So what's happening here is that this is one long text string. And so here Python is just indicating that this is text. It's one long string. Then when I run this part, the string.split method, string.split on the comma, that function is actually adding in these parens around every element, indicating that it's a list here with 0, 1, 2 elements. And so I think if I do another 0. Okay, so it does show here it is again, just indicating that these are text. I don't know. It didn't actually cause me any problems as far as generating the JSON object and then pasting it in and getting the map to display. So parens definitely can be a problem when you're working with text for sure. In this case, it just kind of worked. So hopefully that's helpful.
So it says, so you didn't deal with the latitude, longitude directly.
So that did surprise me that actually worked, but I think I know what you mean now. Is in the geocoding section, I'm actually geocoding, sending it the address, and I'm sending it X. Yeah, I'm sending it the address. So yeah, You're right. We know that the addresses. So yeah, I was surprised that Google Maps, I didn't send it New York City and a zip code. I didn't send it, um, all I sent it was this street address with the cross street, and it got, I think 98% of them correct. So yeah, that was something that I was delightfully surprised by. Delightfully surprised in the sense of making a sandwich map with through the path of least resistance.
One last question I saw here in the chat, I believe it was from Rachel, who's asking, will the Python notebook be available online?
Yes, so it is on my GitHub right now. Um, and then this file, create sandwiches. I think it's blank. Um, but I can upload the one with the results populated as well. And
Oh my gosh, Dan, this was so much fun and informative. And I think you may have inspired a couple people from earlier to actually order sandwiches off the list. So yeah, I think there's a debate that's going to be happening about whether a hot dog is a sandwich. So I guess more on that.
yeah, awesome. Yeah, thank you everyone for coming. I really enjoyed doing this.